Alright, for this week we're going to talk about branching and looping. We've done a little bit of looping so far with our for loops, but there's also another type of loop as well, and we'll get into that. But first we want to cover branching. So branching is the ability to make a decision based on some condition. So if we were working on a flowchart, let's say we ask the user to enter in, you ask user for age, let's just say store in age variable, and I don't remember the exact right shapes for the flowchart, but I know the decision diamond is how we would implement a branch or an if statement. So if age is less than 18, or we could ask is age less than 18, but we do that. And so we could branch two different paths based on what the result is. So for instance, we'll just point this over here, and we'll mark this as true or false. So if it's true, that means, that means age is less than 18. If it's false, that means the opposite, which means that age is greater than or equal to 18. So with this, so over here, let's just say user cannot vote. Whatever code that would end up being, we would put that there. Otherwise here, user can vote. And over here. So then you could write your own like set of instructions. So like print instructions. This is just a very general high-level overview. Print requirements for voting, and so on and so forth. And then maybe over here we would print their region elections going on. And then eventually the program would converge again. So then we would just say like end program. But usually other stuff will happen in a program. But eventually the branches will end and it will come back to the end of the program. So we'll see some of these examples here in a moment. With the textbook, we're talking about Boolean expressions first. And so Boolean expressions are statements that result in true or false, or also basically think of them as yes, no questions. Any of the things we can ask a computer, like if this thing is true, if that thing is true, all of it is going to be Boolean. We can't ask a computer something that has multiple answers beyond just yes and no, but we can ask it yes, no questions. So we couldn't say, hey, what's the user's favorite color? That doesn't work as a question, but we could ask, is the user's favorite color red? Is the user's favorite color orange? And so on. So any sort of statement we write like this, it will either result in true or false. And the main types of operators we have for these are is not equal to, is equal to, which is the double equal sign, so make sure you don't get that mixed up. X is greater than y, x is less than y, x is greater than equal to y, x is less than equal to y. You could also use is and is not in Python, so basically is not and this symbol are interchangeable for us at this point. And then the double equal sign or is are also interchangeable for us at this point. Now, with other programming languages, you usually won't see is and is not. You'll usually see the double equal operator and the not equal operator. So that's probably what I'm going to use the most in the examples. So we'll just start with this. Let's think about simple branching. If we have something that we need to go in one direction or another, and what that would look like in code. So let's say we're writing a program where we ask the user if they have any dietary restrictions. So we'll just have program start. Actually, I think that would be an oval. I always have to reference these things again. So First, we'll just ask, do you, well, let's just do this easy. Let's just say, are you vegetarian? And we'll have them enter yes or no. And we'll store that in some kind of variable, like store in variable veg. I don't know. Then we can do a few things. Let's say either way, they can still have water as a drink or lemonade as a drink. So we could put print lemonade as drink. So that happens either way. But we have this information for a little bit later on. And then, you know, you could have French fries as a side either way. Print French fries as side. But then when it comes to the sandwich, are they able to have a burger or do they need like a black bean burger? So we could put if veg is yes. And so we'll go there. And then we have two results. It could either be yes or no. So over here, this would be veg is yes. And the opposite isn't veg equals no, it's technically veg is not equal to yes. So technically if I wrote P or D to the result of this thing, it would still count it as a no. So in this case, let's say if they are vegetarian, print black bean burger. And then, you know, there's always lots of different types of dietary restrictions, but let's just say print chicken sandwich. Not everyone eats beef, even if they do eat meat. So we'll do that. And then those would converge again. So we'll come back around. Let's just say print price of meal. So it does that either way. And then the program would end. So this is just a very general high-level overview of what a program using an if-else statement might look like. I don't need to say that. So in this example, we'll write this sort of thing out. So program starts, we'll ask the user, well, let's just say menu program. Veg is equal to input. Are you vegetarian? And I'll just prompt them for like a yes or a no. Please enter one of those options. Let me clear this up a little bit. And so no matter what they say, we can still say lemonade, French fries. So we'll put this as drink, side. And then we have to figure out which of these is going to be printed. So I'm just going to say sandwich, black bean burger. I'm just going to tab these over so they all kind of are aligned. Or this could be chicken sandwich. All right. So at this point, they should have entered a Y or an N or technically anything else. But down here, we can say if veg is equal to Y, then we print this one. Otherwise, we just use the else case for anything else that comes up. We print that. That's my alarm. Okay, so we have those, and then we would have the price of the meal. That could differ based on like what the different things are. So let's just put a little float up here. We'll do price is 0. For the lemonade, let's just add, I don't know, $1. Let's just add 75 cents. And then for this one, I don't really know what usually these cost. Let's just say $3.15. I don't know. Price is, we'll put the price. So I'm not formatting it. We're just kind of keeping it simple. If I say yes, I didn't really format that the way I want it. It'll print the rest of this out. I would actually like to put another print in here just to make it look a little bit nicer. We'll run it again. No. Lemonade, chicken, or French fries and chicken sandwich. Or technically, if I enter anything that is not y, that will count as no. So that would be something with like just vegetarian, non-vegetarian. We could also do something like if you're vegan, or if you can't eat beef, or you can't eat pork, or something like that. But in this case, we're just using an if statement. So this internal code is executed if this is true, or this internal code is executed if else is true, which basically, if that doesn't trigger, else will always trigger. Now with these if statements, notice that these are indented by one tab. Anything inside this if needs to be indented. So statements that contain more code will end in a colon here in Python. And then you'll see that it automatically indents in the editor as you do that. So once you unindent, that means we're outside of the if statement. So done with, that's the wrong one, if statement. I've been writing a lot of Lua code, so I get the different symbols mixed up a lot. So that would be an example of that. Now sometimes we do want just a little branch for one scenario, but we don't need anything for the else case. So let's go ahead and think of a little program where we can ask the user something and it's going to continue running, but if our condition is true, then we get a little something extra. So for instance, let's say we'll ask the user for a number, store in variable number, and just to make an absolute value, so if you remember that, a negative number becomes a positive number, and positive numbers are always the same anyway. So we'll do if number is less than 0, that means it is negative. We are going to do something first. We're going to say number is equal to negative number, which will actually turn it to positive, because a negative negative becomes positive. And then we're going to print number. So we'll do that, but let's see, if this condition does not trigger, if this is not true, it doesn't have an else case here. It'll just do this, or it'll immediately go to the next line. So we'll say program end, the end, and we'll write a little absolute value program. Okay. So we'll ask the user for a number. We'll just say, say number is equal to float, input, enter a number. Okay. Now, if the number is 0, before we print stuff out, so this is inside if statement, down here would be outside if statement, because again, I've untabbed. Either way, no matter what happens, we're still going to print the number. So absolute value is number, but the difference is we are changing number if it happens to be negative. So then we'll say number is equal to negative number. And then this ends, and this should not be indented. That should be all the way at the side. So run, let's say negative 100, so the absolute value is 100. Or if we have 5, the absolute value is still 5, so nothing had to change there. So whatever is in here is known as the condition. So you'll hear that a lot. This is the condition. If the condition is true, then whatever its internal code is will get executed. Okay, so that is a basic if statement where we do a little bit of special code if this is true, but we don't have an else case. In this case, we have yes or no, or basically not yes. And two different sets of code get executed either way. With the if statement, there's no else case to execute some other set of code. There's just the if statement if we need to do, like usually pre-preparing something ahead of time rather than selecting between two options. Okay, now we can also use an if, else if statement so that we can check multiple things. So over here, let's come over here, do program start. Let's just say we want to write a little program where we ask the user how much money they have and how much something costs, and let them know if either they don't have enough money, or if they have enough money, but then it'll leave them with a 0 balance, or if they have enough money and they can buy it and they won't have no money anymore. So we'll ask the user, ask how much money do you have, store in, let's say, your money variable. Ask how much does it cost, store in cost variable. Okay, got that. Got that. Now we have these two things. We can figure out if your money is less than the cost, that means you don't have enough for it. So that's one thing we're going to check. If that is the case, we can say print you don't have enough money. And then technically we'd have our end down here. So let's say program end. We're going to add some more in here, but everything else, once it's done with its statement, it's going to come back and hit the end. I don't want it to format that way. Come on. I'll do that. So it'll print that and then the program will end. I guess I'll just save this for backup. Okay, so this is the true case. Your money is less than cost. But if that's not true, then we can check something else. So down here, in this case, false. So your money is either greater than or equal to the cost. That's the opposite. So less than or greater than equal to. So then let's check if your money is equal to the cost. Then in that case, you would have $0 after you buy it. So we could say print, you can buy it, but then you'll be broke. We'll go over here. So in case this is true, that means your money is equal to the cost. And then that will eventually come back down and return as well. See if I can get these to format the way I want them to. Okay. So either way, both of those return afterwards. Now, technically, this is not an if statement. This is going to be an else if statement. But in Python, they're written as elif, but we'll see this in a moment. Else if, and then otherwise, we could also do an else case, which technically means that neither of the above were true. So the else case triggers when your money is not less than cost, your money is not equal to the cost. That means the only other result is your money is greater than the cost. So the else case, this always gets executed. Let's say print, you can buy it and have money left over. Come down here. We could also make this an else if case. That also works. But you can do it in either of these ways. So program start. How much do you have? How much does it cost? And then we figure where to go from there. So let's say budgeting program. I don't know. Your money is equal to a float input. How much money do you have? And so this could also be abstracted further, like if you were writing a big program or like a POS software or something like that, where maybe the user doesn't, the customer doesn't give you the right amount of cash, you would just be like, well, this isn't enough, you need to give more. This kind of logic could be used in that regard. Let's say cost is float, input, how much does the thing cost? Okay, then we can do if your money is less than the cost. This will be, not enough money, so we'll do that in a moment. Else if your money is equal to the cost. Now this is wanting to auto indent all these because I haven't written the internal parts yet. And then else. So this, in this case, will say you don't have enough money. You have enough money, but then you'll be broke. And down here we'll say you have enough money and some will be left over. And then let's just put a goodbye at the end so that it shows the end of the program. If I run this, let's say we have $5 and it costs $5. You'll have enough money, but then you'll be broke. Run it again. We have $10 and it costs $5. You have enough money and some will be left over. We have $5 and it costs $10. You don't have enough money. Another way we could write this is if we wanted to just explicitly have this be your money is greater than the cost. So you could do these. These are all three possible scenarios. It's either less than, equal to, or greater than. But since this is the only other option in this scenario when we're working with less thans and greater thans, we could just keep it as an else. And remember that the else case does not have the condition listed because the else case gets triggered if none of the things above it got triggered. So this is our if case, or if statement, else if statement, and our else. So that's an example of using those. Now sometimes in our statements we'll want to ask multiple questions in one if statement because something is only true, or we only want something to execute if two things are true or three things are true. In that case we can use these logic operators like and, or, and not to adjust our situations. So over here, let's do program start. Let's say we're going to think about ticket prices, but we have like an age range. So if the kid is, let's say, less than 18 but older than 13, they have this price. If they're between 18 and 55, then they're this price, and so on and so forth. So we'll ask the user, ask, what is your age? Store in age variable. So then we can use an and statement to make sure something is between some range. So we could say if age is greater than or equal to 13 and age is less than or equal to 18, so basically a teenager, that would be teenager ticket price. Then over here we would just say ticket price is, I don't know, $5.99. So again, also it's important to label these over here. So we'll just say true. I don't need to type out the entire thing. Okay, if that is false, then we might need to check another one. Let's say if age is greater than 18 and age is less than 55, this would be like your general adult ticket. So we'll set this here. Let's say ticket price is $7.99. So this is when it is true. Okay, we also have more ranges. We have basically retirement age or small child age. So let's just have if age is less than 13, that's going to be child age. Or we can also have, well, let's just make this an or. Let's say that or age is greater than or equal to 55. Then they get the discount. So we'll say ticket price is $3.99. And so this will be the true case. Oops. Now all of these, once we're done setting this price, let's just go ahead and say display ticket price is, and the ticket price, and then the program will end. So in general, we should not have an else case for these. And I'm just going to also put these as else if statements. Because a number must either be less than 13, so that's going to cover 12 to negative infinity, greater than or equal to 55, that's going to cover 55 to positive infinity. So we don't need an else case because we should have all of the options covered here. So technically this shouldn't be true, shouldn't be able to do true. We could make this an else case, but I want to show you the or. So like, I'll just put error. Like this literally should not happen. That if something happens, that means there's maybe a logic error in the programming. Now remember, if all of these are false, they go on to the next else if statement. And then let's hook up the rest of these before we get into the code. Okay. So once we set this ticket price, we're going to come back down and go to displaying ticket price. Move this to the front, maybe? I don't know. Okay, sometimes this program can be annoying. We'll do that. If they got that ticket price, we'll set this. And if they have the $3.99 ticket price, again, it just sets the data and then we continue on with the rest of the program. So we'll set this there. And this comes down here. All right. So we'll go ahead and write this, but we're using and statements and or statements. So over here, we'll do movie theater. Age is equal to, let's just do an integer input. What is your age? If age is greater than equal to or equal to 13 and age is less than or equal to 18, then this is the teenager price. So let's also just put price up here and set it to 0 to kind of get it initialized. But down here we'll say price is equal to $5.99. Else if, well, it's going to be elif in Python, age is greater than 18 and age is less than 55, and this is adult price. Price is $7.99. Else if age is less than 13 or age is greater than or equal to 55. This is going to be child or senior price. Price is $3.99. Then down here, we'll print the ticket price is, and whatever that price is. So we can run this. If we are 5 years old, we get a $3.99 ticket price. If we are 15, get $5.99, 25, and let's say 65. So then we can make different decisions based on some criteria. But we can also check multiple things at once, because if we put age is greater than or equal to 13 without this part, I'm greater than or equal to 13. Most people, a lot of people in the world are. So that would trigger for that. But if we wanted just the teenager range, we would want to put this and statement, because you're a teenager if you're greater than or equal to 13 or less than or equal to 18. So that would be an example of our and or statement or operators. Now with the not operator, we would do something like, let's say vet is input. Are you a vet? Yes or no. So we could say if vet or if not vet, then we could kind of add on to that. So down here, let's just say if, technically this would just be if vet, let's just say price minus equals another $1. Else if not vet, price, let's just add $1. We're just kind of making stuff up here. Actually, this would have to be like is equal to y. So technically, I know this looks a little bit weird, but let's just change this so that if vet is equal to y up here, we'll just say vet is true instead, because that makes it a little bit easier to handle. Otherwise, vet is false. So then we can literally just ask if vet, because if it's true, this will return true. If not vet, then we add 1. Now, this could be an else case as well, because if it's not the vet, if that's false, then it's not vet. But we're just showing off how to use not here. So then in this case, we can say I am 65 and a vet, and then so the ticket price goes down a little bit more. 65, not a vet, then it added $1 more onto it. But this way we could say if we're asking a question, is this true or false, but we're taking the opposite here. If they are not a vet, then we're going to do this thing. We could also get rid of this part and just say, well, if they're not a vet, then just add another $1 to it, which basically gives that discount anyway. So there's the $4.99. They don't get as much of a discount. Oops. They still get like the base $3.99. So that would be a way to use the not operator. So going through the rest of the book and the concept introduction, it will kind of give you some example questions that you can work through, practice with this. These also use the flowchart sort of thing and show you what this looks like. So this modulus operator just lets you know what the remainder of something is. You don't really have to worry about the specifics of the math here, but basically if that is true, then x is an even number. If it's not true, then x is an odd number. And then here is our if, else, if type of statements. We can have an else at the end, but they're not required. Here's a bunch of if and else if statements together. And we can also put if statements inside of if statements. So that looks like this. X is equal to y, yes or no. If they're not equal, then, well, is x less than y? Or is x greater than y? So we could kind of do different steps, you know, branching from different ways. If this is true, we go down this branch, and we go down another branch, and so on. Don't worry about the try and accept for now. This is kind of more advanced than what you need to know, but you'll learn about that in probably the next programming course. So you could skip that. You can skim through this part, but if it doesn't make sense, don't worry about it. We're not going to get really into the weeds with that. And then thinking of debugging, well, sometimes just putting print statements inside of here will help you figure out where it's flowing, or, you know, just to reprint out your money is your money, because sometimes the variables change over the length of the program. Sometimes it can be helpful just to print that data back out to make sure that it didn't get garbled along the way. And then I will also, if I haven't already, okay, I have some vocabulary there. All right, so the other part is going to be working with our while loops and also reviewing for loops. So with these, a while loop is very similar to an if statement, where we have a condition we're looking at, and we have an internal set of code that gets executed if the condition is true. The difference, though, is a while loop will continue executing the internals until this is not true anymore. So an if statement, it only checks it once, it does that one time. A while loop will keep continuing. So over here, we can say, let's just we could do our counters just like we've done with the for loop. So let's just do a counter real quick. For I in range, let's say 1 to 10, print I. So we run that, 1, 2, 3, 4, 5, 6, 7, 8, 9. Down here, we could do the same with the while loop. It's just going to look a little bit longer. So I is 0, while I is less than 10. We are going to print I, and then add 1 to I. So we'll get the same output twice. In this case, it started at 0 because I set it to 0, but I meant to put it at 1 over here. So let's just put, this is the for loop. This is the while loop. Run, and we get that same output. So we are able to do the same counting stuff. For loops are generally better for any sort of counting. While loops we can use for more different types of purposes. So here's the while loop. We have to have some sort of thing to be a conditional. In this case, it's what is the value of I. So while I is less than 10, we're going to print this value out. Now, if I had forgotten to add 1 to I each time, it's going to give me an infinite loop of just ones, because it'll stay 1. 1 will never be greater than or equal to 10. So then the program would just keep looping and basically be a crash state, even though the program technically hasn't crashed. It's just an infinite loop. So we have that. We could also do other conditionals. So for instance, let's say we had print budget. Let's just copy our money part over here. So while your money is less than the cost, we'll print you do not have enough money yet. We'll ask them to add some more, so add money is equal to float input. How much more money to add to your money? Then we'll say your money plus equals add money, so then we'll add more. And up here, let's just also print your money and cost so that we know what it is each time through the loop. And then down here, we're done with the while loop. Again, this is all indented forward by 1 tab. We have this colon right here. Once we return to the base level, I am awake. Sorry, my morning alarm goes off. Once we return to the no indentation, we have exited the while loop. So down here, we'll just say, now you can buy the thing. Goodbye. So this loop will only end once your money is greater than or equal to the cost. So this will still display our loops here for a minute, but let's say we have $1 and the thing costs $10. Don't have enough money. How much more to add? I have $3 more. Okay, that's still four more dollars. Okay, we're at 8. Let's do 4 more. Now we can buy the thing because we have enough money. And it could be useful to put this down here. So let's do that one more time. We have $5, it's 10. We're going to do 1, 1, 1, 1, 1. Okay. Did I just rerun it? Oh, wait, no. It asks me for that again. I did not mean to do that one. I meant to do this one. And I need to make sure to unindent that. If I have this indented inappropriately, it'll, let's see what the error message says. Unexpected indent. Because there's nothing with a colon right before it. So this is not inside of anything. Oh, I did that wrong. We have 5, it's 10, and we can keep going up. There we go. Now we can buy the thing. So our while loop, we have a condition. We need to make sure that somewhere within the while loop, something is happening to turn that condition to false, because this will only stop looping once the condition is false. So with the textbook, it talks about how we can add 1 to x, updating the variables. This is just known as iteration, iterating on something. With our while loop, it outlines what the format of that while loop is, and also gives you information on how to avoid infinite loops, what causes those infinite loops. We can use the continue command, but you don't really need to worry about it. Skim through it. We might not use continue. We're not going to write really complex programs. We have for loops. We've gone over that with our iterating through lists and dictionaries, but this is just more information, more background information about those, and more about ways you can write loops, very common types of loops. So again, at least skim through these, get a general idea, and you can always reference it again later if you need it. So let's go through maybe some other examples with a while loop. Okay, I'm going to write a somewhat bigger program that's going to use multiple things that we've been working with. So import random. Let's do some lines, so that will just display a bunch of lines here. And we're going to print race car, and then maybe another one. Does that look okay? Maybe these will just be dashes. That looks a little bit better. So what I'm going to do is we'll have a series of cars, and they'll each have a random speed, and then we'll have a length of a track. So let's say track length is 20, and each cycle, the while loop will keep basically going forward until someone hits the finish line. But at each cycle, it will move each car forward by whatever its speed is. So I'm going to create an array of cars. And I'm going to make these dictionaries as well, so we have more information. So let's say the name of this car is a Taurus. Its speed is going to be some random value, so random.randint. Let's just say 1 to 5. And its current distance traveled is 0. Because they were all going to start at the starting line. We'll change this next one to an accord. Versa. So they'll all have a random speed. And we're also going to check if the race is over, which starts at false because it's not over, and how many minutes have passed. So each time through the while loop, we'll just say 1 more minute has passed. So first up, let's display the car stats to the user. Let's just iterate over each of the cars. For car, in cars, we can print the car name. Starts at car distance, which is up here, and speed is car speed. So that will just be the basic display. We can print new line, and let's just say input, press enter to begin the race. So I'm not setting this to any variable because I just want them to hit enter. I don't need any information from the user. So far, if we run this, I just hit enter and then the race would start. So our condition will be while the race over is not true, so we'll just put not here. While not race over, we're going to add 1 to the minute. So a minute goes by each time. Let's print, I don't want that. I still want it indented. Sometimes it'll unindent it for you. We'll do this, print minute, and then the minute. And then we'll go iterate through the cars again because we need to move each car forward. And again, it unindented me, but I want this indented. For car in cars, these are all supposed to be in the while loop. And now over here, notice I'm inside the while loop and I'm indented twice. I mean, I'm inside the for loop and I'm indented twice. So this code is all inside the while loop, and anything I put here is inside this for loop. So we're going to move each car forward. Let's just print their information. So car name is at, let's do a tab here, car distance, and I'm just gonna do like a slash and put the total length of the thing. So track length, how much they've completed. We'll also check if the car distance is greater than or equal to the track length, then the race is over. So we'll set that to true. Okay, now this is where it can get confusing. So I'm 3 indentations deep here. This is for the if statement. I don't want any more information after this, so I'll just put end of if, just kind of mark that. Now, anytime through the loop, we're going to want to change the distance. We can do that here or down here. It kind of depends on how we want it to look. We'll say car distance plus equals car speed. Okay, and then that's going to just update each of the car. End of for loop. Still in the while loop. Probably want to maybe just get another enter so it doesn't run, you know, super ahead before we can read what's going on. End of while. So this will keep looping until something hits the end when race is over, so that it only ends whenever at least one car hits the end of the track. At the end, let's go ahead and just print some extra information. So we'll do dashes, print race over, and let's print final positions. Oops, this is supposed to go inside there. And we can again iterate through each car. Print each car's position. So car name at car distance. Okay, so that will show all of that information. Let's also put the tab here. So when I run this, we have these, they have random speeds. We'll hit enter. So the first minute, they are at the beginning of the thing. Actually, I'm going to change this to say enter to continue. Now they have a little more competitive, still not great. No one can compete with this Accord, but they start at 0. We hit enter at the second minute, you know, not really real speeds or anything like that, but we have a Taurus is at position, like, you know, let's think of X coordinates, like an X coordinate of 2 and a X coordinate of 5 over here. And so as we keep going, they keep moving at their speed. So we go from 2, 4, 6, 8 for the Taurus. The Accord is clearly going much faster, and it has gone past the finish line, and this is where everything ends up. So this Versa is not doing very good. It's just kind of crawling along behind. But here we use for loops to display data in our cars list. We used a cars list with dictionaries for each car. And we used a while loop and an if statement all in this one program. So this is how things kind of come together to make a more complex program. So those are the topics for this week. These are pretty important, but they can take some getting used to kind of thinking through that way. So definitely ask any questions if you have any questions. And with the branching and looping exercise, we can look at this real quick. But we'll have actually quite a few of these exercises, so make sure you just go through them. But we'll start with one with just an if statement, just an if-else statement, something with if and else if statements, something with our and operator, something with our or operator. So those are all branching parts. A sample program to calculate a grade, and a sample program to guess a number, like a little number guessing game. So that is that for this week.